Okay, assignment 5, part 3. First topic, finding a difference quotient for a linear or quadratic function. So what we're going to do is evaluate, this is the difference quotient. All right. So here's our function. What we're going to do first is plug x plus h in for x. So we go 2. Okay, so x plus h goes in for x. So you put the x plus h minus 1. Okay, so that's f of x plus h. I put x plus h in 2, x plus h minus 1. Always use parentheses. Minus, always in parentheses, f of x, which is your original function. All over h. Now, if you do these problems right at the end, the h's will cancel, and you're kind of getting into some things we use in calculus down the road. All right, so first thing, distribute the 2. So 2x plus 2h minus 1. Distribute the negative 1. Negative 1 times 2x is minus 2x plus 1 all over h. So what will happen here is the 2x's cancel and the 1's cancel. And because we're just dealing with quadratics and linears, everything without an h should cancel. So you're left with 2h over h, and now we can cancel the h's. So you're left with 2. So all I did was I plugged in x plus h for x. I got 2 times x plus h minus 1 minus the original function, all in parentheses. I distributed the negative 1. Combine like terms. Those cancel, those cancel. If your non-h's don't cancel, you probably messed up a sign. So just go back and check. Make sure you distribute right. Make sure you distribute the negative 1 right. All right. Let's try one more problem that's a little more difficult. So this is problem 2. Okay. This is going to be a bit more work because now we have a quadratic. We're going to have to FOIL. So first step, we have a negative. We're going to plug in x plus h for all x's. X plus h squared minus 6 times x plus h plus 7 minus the original function, negative x squared minus 6x plus 7 all over h. Okay, to help you out, always, 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 this x plus h squared. Notice the negative goes on the outside. X plus h goes in for x, so it's negative x plus h squared. All the time, x plus h squared is x plus h times x plus h. So if you FOIL this, it'll always come out to all the time x squared plus 2xh plus h squared. Because if I FOIL, I get an xh and an xh, which is 2xh. You're not used to seeing two variables, but that it works out. It works out that way. Okay, so when you FOIL this, you get this. All right, so our next step, we get a negative. You can do this in one step if you want. I'm going to do it in a couple steps. So that's the x plus h squared. Now distribute the minus 6. Minus 6x minus 6h plus 7. And distribute the negative 1. Plus x squared plus 6x minus 7. All right, now all over h. If you want to skip that to the end, that's okay. Just don't forget it. All right, now we're going to distribute the negative 1. So we get negative x squared minus 2xh minus h squared minus 6x minus 6h plus 7 plus x squared plus 6x minus 7 all over h. And if we did this right, all your non-h's should disappear. So negative x squared and x squared cancel. Minus 6x plus 6x cancel. Plus 7 minus 7 cancel. Okay. So we're only left with pieces with h's. Okay, now the last problem was linear, so it was nice and easy. The final step for all quadratics, I don't think it'll happen in linears, but definitely in quadratics, is you have to factor out an h. So then we can cancel. So negative 2x h squared, take out an h. We're left with a minus h. And minus 6h, take out a h. We're left with a minus 6. So the GCF here was an H. You always just take out an H. You can leave everything else. So take out an H, take out an H, take out an H. This is what you're left with. This cancels, and you're left with negative 2x minus H minus 6. Okay. Then one day in calculus, which is not now, you'll plug in 0 for h, and that'll mean something. But we're not doing that in this course. But if you ever take calculus, you'll see this later on. Okay, so a bit of algebra here. You have to be really careful. Careful with your distributing. Factor, once you get here, you're always going to factor out an h, and then they'll cancel. Okay, you can kind of shortcut that a little bit, but you really shouldn't cancel to your factor. But some of the stuff you could do in your head. All right. So next, we're looking at increasing decreasing and constant functions or graphs. Forget what they label it next. Graphs. All right. So remember, this is kind of like a book. So I'm going to read it left to right. Left to right. So just a quick example. This would be increasing. This would be constant. So put con for constant. This would be decreasing. So left to right, you're going up. Left to right, you're staying flat. Left to right, you're going down. So this is increasing going up, decreasing is going down. All right. So hopefully this is a really easy piece of Alex. Let's take a look. Number 1. So they want you to look at each segment and tell me if it's increasing, constant, or decreasing. That's all they want you to do here. I'm hoping this is a nice section for you. Okay, so if you want to try this, I'll pause it. On Alex, you'll just click these. All right, I'm going to continue on. So A to B, we're going up, so we're increasing. B to C is constant, going straight across. C to D is going down, so it's decreasing. And D to E is going straight across, that's constant. Okay, that's all they want you to do there. Hopefully that's pretty good for you. All right, let's move on. I'll give you another one. Okay. So next section, I just put the question on the next page. Finding where a function is increasing, decreasing, or constant given the graph, interval notation. So for all these, we're always going to use parentheses. Okay. We're always going to use parentheses and your answer could be none. I'll show you that after. Okay, so we're always going to use parentheses. All right, first problem. Determine the intervals where the function is strictly increasing. Write your answer in interval notation. All right. So where are we increasing? Let's look at this graph. From reading a book left to right, where's it going up? All right. It looks like it's going up right here. And that's it. So now they want the interval we're listing are x values. So we always list, or no, we not list, but we're going to use x values in the intervals. Okay. So this is the only part of the graph that's increasing. So it looks like it's -7. So I'm going to start at -7, and we're going to go to, it looks like it's -4. Remember, these are the x values. So this dot's at -7. This dot here is at -4. Always use parentheses. And that's all they're asking for there. Just find the interval where it's increasing. So that was number 1. Let's take a look at number 2. Okay. Strictly decreasing. If you want to pause it and try it, go ahead. I'm about to continue on with this problem. So where are we decreasing? So looking left to right, where are we going down? Well, it looks like right here, and it looks like right here. And if it says if you use more than one interval, put a comma in between. It wouldn't matter really for me for a test. All right, so this looks like it's -5 to -3. So -5 to -3. And if we were using Alex, we put comma. And there's another one here. So it looks like it's 2, right? We line that up 2 with 6. So 2, comma 6. So that would be your answer. That's where the function is decreasing. It's strictly decreasing, which means it doesn't change in that interval. That's all it means. It's just decreasing. Focus on. And let's say here, let me just give you a quick example 3. Let's say our graph is increasing, constant, and increasing. If they ask you where is this graph decreasing, where is this graph decreasing? Okay, that would be you would click none. Okay, so that would be a click none on Alex. I didn't copy one of those from Alex, but so if it's increasing, constant increasing, and they ask you for decreasing, you have the option of clicking none if applicable. Just a heads up for that. Okay, next piece. Local minimum. Usually when I'm writing, I'll go min and maximum. And when I'm writing, just to make it shorter, usually I'll just say max. Okay. So let's just say we had a graph. Let's say we had a graph that looks something like this. Okay. This point up here and this point up here, even though these are not the same height, those are both local maxes. So the top of a hill is a local max. It doesn't matter how high that hill or mountain is. If it's the top, it's a max. And down here, that would be a local min. And even though the graph goes on forever, both ways, to the left and to the right, it's still, this is a local, because it's the bottom of a valley or top of a hill is a max, bottom of a valley is a min. All right. All right. So on Alex, not a bad question. They want to you to find all local minimum values. So A are the y values, y value or y values at all values at which f has a local min. These are okay, so these are the y values and these are the x values. Be careful. I was just looking through Alex and sometimes they switch the order. So they want the local min or max, that's the y values. All values at which f has a local min or max, that's the x values. So sometimes they switch those up. All right, so let's look. They want the min. So the minimum values, the bottoms of the valley. So we got this one and this one. Those are bottoms. So the y values there are -2 and -1. The y value here is -2. The y value here is -1. So I'm going to put -1 and -2 for that one. Where does it occur? Well, that's the x values. Where does this occur? When x is -1 and when x is 3. So we're going to go -1, 3. Okay. Be careful if they switch that around. Okay, so the min value is the y at which f, the values at which, those are the x values. All right. So that was number 1 there. That's our topic. Okay, let's try one more. Sorry about that. There we go. Okay, so just be careful here. All values at which x, so this one's opposite. So this is the x values, these are the y's. Okay, so we want a local max. So we want the tops of the hill. So local max. So let's start with the x values here. We have -1 and 3, just like before. Okay, so those are our x values. And the heights of these are the same. They're both at 2. So all we have to put for this one is 2. We don't have to repeat 2. If those were different numbers, we'd have to write both of them down. So both of those have a y value of 2. And that completes this video.